Cytochrome and complex 4, cytochrome C oxidase. Cytochrome C carries electrons from complex 3 to complex 4, cytochrome C oxidase. At complex 4, electrons are transferred to molecular oxygen, O2, which serves as the final electron acceptor, forming water, H2O. You usually respire that water, I think. As electrons move through complex 4, protons are pumped across the membrane. As electrons pass through the electron transport chain, energy released from their movement is used to pump protons from the mitochondrial matrix to the intermembrane space. This pumping creates a proton gradient or electrochemical gradient with higher concentration of protons in the intermembrane space compared to the mitochondrial matrix. So we're forming that charge. Now this is the cool one. ATP synthase, or by ATP synthase complex 5. ATP synthase is an enzyme complex located in the inner mitochondrial membrane. The flow of protons, they want to go back to that, they're attracted to each other, right? They're repulsive of each other, and they're attracted to the negative matrix space on the inside where they came from. So they want to pass through this. Now this is the really cool molecule. The flow of protons back into the mitochondrial matrix through ATP synthase channels drives the rotation of ATP synthase. Like water flowing through a turbine, these electrons are flowing, attracted to the inner matrix. They have to pass through this like water flowing through a turbine, and that coupling of the movement to protons to the synthase to form ATP from ADP, an inorganic phosphate. So that spinning of the is taking ADP and forming ATP in this like kind of, assembly line cycle. This process is called chemiosmotic coupling, and ATP synthase acts as a molecular machine that produces ATP as protons flow through it. The exact numbers of ATP molecules produced per molecule of NADH and FADH2 varies due to factors like subtle system and proton gradient strength. Generally, the oxidation of one NADH molecule results in the production of approximately 2.5 to 3 ATP molecules, while the FADH2 molecules yields 1.5 to 2 ATP molecules. In summary, the electron transport chain comprises multiple protein complexes and coenzymes that work together to transfer electrons, pump protons, and create a proton gradient, the lightning in the bottle, across the inner mitochondrial membrane. This gradient powers ATP synthase. That's the molecule that spins when the things flow through it like a water turbine. By ATP synthase producing ATP from ADP and inorganic phosphate. The electron transport chain is fundamental to cellular respiration, generating the majority of ATP used for cellular energy.